All right, we're doing some amazing job here with our hypothesis testing. Let's talk practically, right? So let's also talk to a practical significance. We've talked statistically significant, right? That's how we know. Do we reject it? Do we not reject it? So it can be statistically significant when we crunch the numbers, but there's also a thing called practical significance. This is real data. All right, so we want to make sure whatever we're doing with real data makes sense. So practical significance refers to the idea that while small differences between the statistic and the parameter stated in the null are statistically significant, right? That's how we determine if we reject or not. The difference may not be large enough to cause concern or be considered important. Cause concern or be considered important. May not be practical, right? So where it may be statistically significant, so the numbers may play out. However, is there a practical significance? Is the difference big enough to even be considered important, right? Part of what this class does is make sure that you understand the reality of what it is, right? Somebody can throw numbers at you, but if you are educated enough to be able to determine what they mean, that just puts you a step ahead. And that's kind of where this practical significance comes in. All right, so check this out. Here's just a little side note just to make sure you're on board with it. Large sample sizes can lead to results that are statistically significant, while the difference between the statistic and the parameter and the null is not enough to be considered practical. All right, so it could be statistically significant, but you just have to make sure you're paying attention to the practicality of it. All right, let's look at this example. According to the American Community Survey, the mean travel time to work in Collin County, Texas in 2017 was 29.3 minutes. The Department of Transportation reprogrammed all traffic lights in Collin County in an attempt to reduce travel time. To determine if there is evidence that travel time has decreased, there's a keyword, as a result of the reprogramming, the Department of Transportation obtains a random sample of 2,500 commuters, records their travel time, has a sample mean of 29 minutes, and a standard deviation of 8.5 minutes. Does this result suggest that travel time has decreased with 95% confidence? Okay, so back to the drawing board again, right? Yes, we're talking about travelers here. The sample that I have in Collin County, Texas, a big county, right? So our sample of 2,500 commuters is less than 5%. It is normally distributed that we're looking through. So good all around good. Okay. Here is our null and our alternative hypothesis. And I'm getting tongue-tied. So it is the mean that we're looking at. And what are we starting with here? What's it say? 29.3 from 2017. So we want to see if that's different. So 29.3. How is our mean different? What do they want to know? Decreased. So we want to know if this is less. Has it decreased? Right? Okay, what other info do we have from the new stuff so we can plug that in? 2,500 commuters, that's our N. A mean of 29, standard deviation of 8.5. Let's have StatCrunch do its thing. So this is mean, so we know we're doing T-stat here. We're still at one sample, and I'm going with a summary because I have all the information. So my sample mean was 29.0, so same thing as 29. The standard deviation is 8.5. And the sample size is 2,500 commuters. Our mean is 29.3. And we want to know if this has decreased. So it's less than with the decrease, right? And then what's our p-value? So our p-value here is 0.0389. 0.0389 is our p-value. Oops, let me scoot this over here. So the oh dang it, I don't want to do the highlighter. The p-value is 0.0389, right? Isn't that what we said? Yeah. So is this less than my level of significance? So 0.0389 is less than 0.05. So yes, it is less than 0.05. Is it statistically significant? That is what we're saying. So we reject because it is statistically significant. The null. Null, right? So this means statistically significant. So then that's where we write our statement. There is sufficient evidence. To conclude, the mean travel time to work has decreased. The mean travel time to work has decreased. All right, so that is statistically significant. So if we're looking at this, we're like, yes, it has decreased. Wow, that's awesome, right? Awesome, way to go. We recalibrated these, or reprogrammed the traffic lights, the commute has decreased, but look at what it has decreased, right? It has decreased from 29.3 to 29.0. 0.3 of a minute. So statistically significant, yes. However, it has decreased 0.3 minutes. Do you know how many seconds that is? 18. 18 seconds. So in terms of travel times, do you think 18 seconds is really going to make anybody feel better? Does that really make anyone feel better about commute time? So it is significantly less, but is it a practical? I'm going to make this is it practical significance? Can we go about and say, oh yes, 18 seconds has been shaved off of your commute time? Well, thank you, right? I think we need to come up with a different plan. If this is what we're really doing here, yes, it is statistically significant, but practically, I don't know. I don't think 18 seconds is going to be a deal breaker in terms of making these changes, right? So to be a good consumer, think about the practical significance, not just, oh, there is sufficient evidence. Oh, we're all in. Still use your brain, right? And make sure that it makes sense in order to make these changes. Practical significance is also good. All right, good. You guys are doing great. Keep up the good work. I'm so proud of you.